All right. Thank you guys so much for attending this discussion. I'm really, really excited for this one because I've been waiting my entire life for robots to come into the home and do all the stuff that I don't want to do because I hate doing laundry, I hate doing dishes, I hate putting away all the toys that my daughter leaves everywhere. And I feel like we're finally about to get to the point where we're going to have robots in the home to do all these things for us. Who else is really excited for home robots? Because this is the most packed I've seen this place. Yeah. First, I want to introduce the panelists. We have Jack Monas from 1X. Jack is a research scientist. He's working on world models at 1X. And 1X is making Neo, which is a humanoid robot designed for the home to help you with things around the house. And then next, we have Con Drogas. He is the CEO of Weave Robotics. They're shipping the Isaac Zero, which is a home robot designed to fold your laundry. And I can imagine there's a lot more that you guys will do in the future. And finally, we have Tony Zhao, who is the CEO of Sunday Robotics. They're building Memo, which is a multi-purpose robot for the home. It's a bimanual robot on a wheeled base. It looks like a big Lego, which is really cute. Yeah, awesome. Let's get right into it. So the first home robot that I had was in 2006 when I bought my first Roomba. And I thought that was revolutionary because I now did not have to vacuum anymore. And I was hoping that it would just keep getting better and better from there. But then for the next 20 years, it didn't really change much. The vacuum got a little bit better, the path planning got a little bit better. Now it can scrub the floors along with vacuuming, but hasn't really changed much. But most recently, I'm seeing a lot more companies building robots for the home. And I wanted to ask you guys, what are the technical changes that have happened recently in the last couple of years that's really enabling this new wave of robotics?
I think there are a couple things here. The obviously like the supply chain for hardware manufacturing, assembly of actuators, metals, and everything has matured quite a bit. Is this not working? Yeah. How's this one? Much better. Okay. So obviously, supply chain has manufactured quite a bit over the past 10 to 20 years. It used to be that if you wanted a robot arm to do some research on, it would cost you $250,000. But now we're at a place where even small companies can prototype their own arms. We can order actuators that are actually useful for a couple $100 with very low quantities. We can prototype our own structural components, our own aesthetic components. And this has really reduced the barrier to entry for small companies. And small companies tend to take risks, and big companies tend to not take risks. And I think that has been a big enabler in exploring this new product category, so that companies like ours can go and build a fully in-house home robot. At the same time, there's been a lot of strides in research by great researchers like Tony, who've really enabled kind of like the field to move forward. Also, with the help of like strong pre-trained backbones that allow you to basically get to like a useful policy um, with much less effort and much less data than before.
Yeah, I mean, just to echo that, seems like it's working now. Good. Yeah, I'd say developments in kind of AI, like as Tony's work has kind of paved the way for a lot of what we do today. And when you look at the Roomba, for example, it's one of the few consumer robotics platforms over the last decades that had success. And the primary reason for that is, of course, like cleaning a floor is one of the easiest things that you can do at home. You can actually just use simple rules to do this. And there's a fun analogy between Roombas and simple worms called nematodes from this book called, I see some smiling faces, maybe you've read this book, called A Brief History of Intelligence. Check it out. It's a fun book. But these nematodes, these simple worms, kind of use very basic cues, if the environment is too hot now, kind of turn around and move in a different direction. If you kind of can smell food, move in that direction. And Rubas, operate in a very similar fashion. If you sense a contact force with the wall, it means you should probably turn around. If you're low on battery, you should probably drive towards the signal of your charger. And this works for, cleaning a floor, but as you scale to more complex tasks that we hope to perform in households and unstructured environments, this simply doesn't scale. So, of course, neural networks are the answer here. Really be kind of pre-trained backbones that we've seen ELAs and formals, which we'll get into later, provide representations that allow for physical understanding, that task understanding, and this I'd say is the most word development over the last decade or so that is enabling this push towards general autonomy.
Yeah. So to repeat the question is the why now for home robots, right? We've seen like lots of previous types of single purpose home robots, and why suddenly there are a lot of people working on trying to put robots, general purpose robots, into people's homes. So I think again the answer is like software and hardware. Hardware, I think we as Khan talked about, there's just a maturing of supply chain that in the past you cannot imagine just getting an actuator off the shelf that you can just plug in the wire and it will work. But instead, you need to do a lot of the really hard work to put together the motor with a gearbox and the controller and all those things. But right now, it's just a lot more simplified. But at the end of the day, I think for hardware, its cost and complexity will go down if there's enough scale and there's enough demand for it. So I think the actual, at a more fundamental level, the driving forces is really the intelligence that we are witnessing. That really propagates from computer vision to large language models and then to robotics. And what we mean by that is if you think about like previous generation of robots, they really cannot only work in factories because they do not have the intelligence. They're just repeating the same motion over and over again. But if you look at the current generation, the robot is reactive. The robot is adjusting based on what is perceiving the world. And so it's really I think the bottleneck has been shifting to mostly AI. And you can even find, I think, videos from like more than 10 years ago with PR2, which is two parallel groupers that can do with teleoperation a huge amount of tasks. So when it comes to home robot, I think the bottleneck is really not the complexity of the robot, as in like if you have legs or like dexterous hands or, something that matches exactly what a human can do, but getting a simple and effective hardware to have to possess the intelligence that a human can and being able to adapt, being able to like generalize. So to me, that's kind of the why now for home robots.
I think the PRE for this, I heard of. Yeah. I think the PR2 is a good example. I think the only thing I would say to that is it was loaded with a lot of hardware on it. So it was essentially like a washing machine on wheels, right? Now we can get a lot lighter. Now we can go a lot smaller, which I think is fundamentally different than 10 to 20 years ago. And to your point, it is definitely enabled by AI. The fact that we can do that, we don't have to have this like huge thing with a ton of sensors all around it.
So, what are some of the tasks that used to be really hard for robots that is becoming easy that you guys are able to do now? And what are some other tasks that you guys are looking towards enabling on your robots?
I think the field has voted with action that laundry folding is the biggest breakthrough in human history for robotics in this era. Because it's true that like with classical system, imagine like solving a task like this, you need to do like very precise pulse estimation of t-shirts. And the t-shirts don't fundamentally have a pulse. It's just like millions and trillions of elements of atoms that it's really hard to capture with any representations.
But what this generation of neural networks are really good at is to perceive just like human with the end-to-end system, so that you can do pixel in and action out. And this just, it turns out that you don't need to do the post estimation of the perfectly of the shirt in order to learn how to fold it.
Yeah. So I think for us, the way we see use cases and what we tackle is obviously we're thinking about what we want to do holistically in the future as well. Um, this is a completely new product category, and we want to make sure that we and do a really good job with it. And so we started with laundry folding. It's something that everybody does, right? Some people might be surprised, but there are households here that do laundry literally every day for 1-2 hours every day. Both parents working. It is something that like scales with how many kids you have, right? So we're focused on doing a really good job with that, so that the clothing our robots fold does not have to be refolded. It is worth being put into real drawers. And we obviously think about the future and other use cases that we want to add. But first, we want to, with Isaac Zero, which is the robot we recently started shipping to customers in San Francisco, we want to make sure our customers are very happy and that our robots and us as a team earn the right to talk about other use cases.
Yeah. Similarly, we take a holistic view at 1X. User workflow that we're particularly interested in is something simple like go to the fridge and grab me a Coke can or turn it. This is a simple task, but there's quite a bit of complexity involved in this. You have to use some kind of high-level reasoner to break this up into subtasks. You then have to trigger some kind of RL locomotion controller to navigate to your fridge, maybe downstairs, maybe upstairs. And then when you get to your fridge, there is a kind of complex interplay between various models to actually open the fridge, retrieve the Coke can, and then deliver it back to you. So we feel comfortable with tasks like this. There are tasks that we kind of try and push our robot to do that do not succeed. And what we've kind of been training our higher level reasoner to do is to phone a friend, which is a remote teleoperator, to then come in, kind of observe the situation, take control of the robot virtually, and then complete the task. And so, this, as we've made very publicly clear, is kind of our first steps to deployment. And then, the hope is this naturally provides recovery data, and would not be necessary as we, scale beyond kind of our first initial deployment.
Since you mentioned teleop, I wanted to ask a quick question, which is like, do you think that having a way to teleop the robot will be something that will always be required? Or do you see a future where you can reliably trust that this robot is almost 100% reliable in its task and won't need it?
Yeah, I think there will, for the foreseeable future, be some kind of post-training phase with teleoperation data. I think this is a different spirit than what you're asking, which is the supervision. And I think kind of our goal at 1X is to, as quickly as possible, move away from this stage where we do need supervision. And we don't expect this to happen immediately. But certainly, the long-term vision of the company is to not require the supervision and to be fully autonomous.
We view it pretty similarly too. At the end of the day, what we're focused on is making sure the robot does its job right. And like our laundromats and our robots and laundromats in San Francisco, for example, go through very messy mixed laundry, like hundreds of pounds every week. And there are cases that we hit where the model that we have has never seen this kind of weird shirt from the Summer of Love back in 1965 with the weird shape and sizes, that we have to like phone home essentially, and have like a weave specialist like go in and do like a 5 to 10 second correction. The curve on that has been quite steep, as in when we first started, which we deployed our first robot, I think last August. We were running around like 60 to 70% autonomously. We actually recently released this like blog post with physical intelligence, actually, but we're now running at this laundromat for like north of like 92%, sometimes like 99, 98% for real loads every single day.
Yeah. So for teleop, I think our what we think about it is it's a very effective tool, but we don't think it is the main source of data that we'll be using to train the models. Just because if you're thinking about the North Star of building a robot that can be general purpose, like the physical AGI, if you will, the amount of data that we'll need is so huge that we don't think teleoperation is going to be scalable enough. But I think it is a really great tool for during deployment. If you look at Waymo, when they deploy their autonomous robots, there's of course still people who can do interventions when needed. So yeah, we think about it as more of a way to accelerate deployment as opposed to the main source of data that we train on.
Got it. Well, let's talk a little bit about the hardware and the design of the robot. So one thing that I've seen in the robots that you guys are building, that the design is very, very intentional. And I'm assuming there's definitely reasons behind that because you want it to be in your homes. Could you talk about some of the decisions that led to how you ended up designing the robot? And also things like how you design the actual hands. Is it actually like a human-like hand or just a two-fingered gripper versus the Memo, which has a very unique three-fingered hand design?
Yeah. Maybe I can start with the hand. So I think the main framework we think about is if you imagine a plot, the x-axis is the number of actuators or number of dots for the hand, and the y-axis is what percentage of human task it can do. I think this curve is going to be really steep in the beginning and then like really quickly plateau. As in like if you have no degree of freedom versus 1 degree of freedom, as in like a gripper, you can suddenly do a lot more. But if you already have like 22 actuators, adding another one really doesn't give you that much. But proportional, or if not quadratic, to the number of degree of freedom is the cost, and the easiness to do maintenance is like all the things that comes with it. So for us, the framework is just like picking the best trade-off given where we are at, both in terms of the ceiling of intelligence and in terms of the manufacturing capability, the matureness of the supply chain. So yeah, this is how we think about the hand, which is really it's all about trade-offs because robotics is all about systems, and systems are all about trade-offs. I think for the robot embodiment, in terms of design, I think there are maybe two things that is worth highlighting for Memo. One is I would say the fact that we didn't go with legs, we go with a wheelbase. So the thinking there is that, yes, we think that if we look like 10 years into the future, 20 years into the future, I think we'll agree that the ultimate form of these robots will be humanoids, will be with legs, with hands, and all good stuff. But I think the fact that it converges to that doesn't mean that it's going to be the first iteration. And it's almost like we're all trying to build an iPhone without ever seeing what a phone is, what is a smartphone. And I think it's because it's such a revolutionary product, being able to iterate with a subset of the capabilities on a subset of homes, but seeing the pipeline all the way through from like data collection, intelligence, of course, like manufacturing and product and even marketing, is tremendously helpful. And we almost think about it as like earning the ticket to build the ultimate robot that will be everywhere. I think the other thing that is worth highlighting for Memo is the industrial design. And one particular thing we do that is somewhat, I would say, different is we do not put these cameras necessarily into the eyes of the robot, which is actually like if you are like, hey, oh, I'm first critical thinking, human has eyes there, why not just replace it with cameras? But I think the way we think about it is like, imagine a future that these robots are ubiquitous. They are like literally everywhere, and you will be forced to see his face every single day. And the question is, what kind of robot face do you want to see? And for me and for a lot of the folks who are participating in design, we find it a little bit off-putting, a little bit strange if you're always looking at like two cameras watching you. Almost feels like you're living in some dystopian future. So the way we do instead is the robot has a hat, and we hide a lot of the sensors underneath the brim of the hat. So when you look at the eyes, it's almost there for emotional reasons as opposed to functional reasons. So this is one thing that we do is I would say like slightly different from a lot of the humanoids that I would say don't even have a face. That just has a mask that it feels like you're looking into the void almost. Yeah, so that's a few things on the design of the robot.
Yeah. The way we thought about Isaac and Isaac Zero from the get-go when we were sketching it out before founding the company was how it should really feel in a home. And one of the things that a lot of people that haven't seen or been around humanoids, full humanoid robots before, note is how loud the footsteps are and how when you see it move, you suddenly do not feel safe anymore. In this way, home robots with robots with arms, manipulators are very different than other consumer hardware. But at the same time, at its core, having a robot in the home is about how it feels. So when we were kind of like originally coming up with the collapsible torso that can go all the way around, all the way down, so that it's short when it's not working, with a wheeled base, so that it's stable, was when we were sitting on a couch and thinking, okay, how should this thing feel when it's charging? How should it feel when I'm in the bedroom also doing something and it's folding side by side next to me? And a lot of the high level decisions we make around the design stem from that. Um, One of the other lessons that I got from my years at Apple is building hardware products is extremely hard. Building a completely new product category is completely different ballgame. Um, so before you have a new product category, before you have a generation of products, you have to have a core. You have to have a core that is really good, that works really well, and you have to build up from it. And this comes from simplicity and asking the question, do I need this feature? Do I need this many degrees of freedom, or do I absolutely need that thing on the shoulder or something? And this is not like purely, oh, this is like a minimalist kind of design vibes thing, but it is more about you cannot revert a feature in hardware once you've shipped it. So a lot goes down from simplicity and finally utility. And that brings me to the hands and the grippers of our robot. So we have parallel grippers. So they're small, they're light, they're quick, and they're silent. We designed them in-house. We're on like the 5th generation of them now. That's what we're shipping publicly, at least. And they work great for the task. And as we look towards future use cases, we obviously have in-house designs that we haven't released publicly yet, but for Isaac Zero, we think it's the exact right design for the right time.
For Neo, the company has spent the better part of the last decade focus solely on tendon driven actuators. And this has been the guiding principle behind Neo, which is safety. If you are going to be in the home, it is inevitable that you will run into people, objects, and just generally delicate things. So this is something that cannot be avoided. So you really have to build this into the hardware. This means back hardenability. This means, in general, soft exterior shells. I think there's generally been a push in this direction. but this is something that 1X from its origin is focused on. So safety is the most important thing to us. I'd say a second factor is, in the spirit of um, targeting kind of the end use case of diverse homes, we have decided to use a bipedal robot. And there are complexities with this, of course. It also opens up um, avenues to many different homes as opposed to ones that have predominantly flat floors. And then, of course, additionally, we have highly dexterous hands. And so there's a few reasons that we've decided to do this. One, we really believe in transfer from human learning. This is something that we're betting big in. And we believe that, there's some stuff I can't talk about, of course, publicly here, but we believe that we can actually get to useful dexterous hands much quicker than, say, other competitors think. And then finally, the aesthetic of the robot is incredibly important if you want this to live in your home. Your home should not, be a factory. There shouldn't be a Terminator in your home. It should really, fit the aesthetic of the interior of your home. So I wasn't involved in design decisions like these two were, but I would say that Neo generally has, in my opinion, a very friendly demeanor. And I've kind of interacted with it in companion mode and felt generally kind of like an RTD2 buy with legs. But yeah, I would say guiding principle at 1X is safety first and foremost. And yeah.
I think the Neo is also pretty lightweight. Right?
Yeah. So Neo is just under 70 pounds. The reason being, of course, software issues will arise. When Neo is deployed in thousands of homes, there will be instances where, say, there's a battery failure and it collapses, in which case the back drivability, the lightweight embodiment is incredibly important.
Yeah, thank you. All right, let's talk a little bit about the software side of things now. First, I don't know if everyone here is an expert in robotic foundation models, but I'd love for you guys to kind of talk about VLAs, world models. What are the differences? What are the pros and cons of each? And where do you guys see robot foundation models going in the next year? Because I feel like every other week or maybe even every week, I see a new model show up on Twitter and it's claiming to do all these new things that previous models weren't capable of. Love to hear your perspective as you guys are actually working on building the models.
Yeah. Maybe we can start off with a definition of VLAs. VLAs, visual language action models, are built on top of VLMs, which are similar to LLMs, except they have an image encoder. So your VLM is processing text tokens and image tokens, and then predictive text tokens. And through this text token supervision, your VLM generally learns semantics, general language understanding. What it does not learn is dynamics. And overall temporal structure of the world. So then, you take this VLM, which does have great semantics, but then, you bolt on a few layers to then train your kind of action head. And this is, I'd say kind of state-of-the-art approaches in the past few months have kind of consistently shown different architecture tweaks to these VLAs. But I would say what they do depend on is having most of the kind of temporal supervision coming from this action supervision. So you have to learn physical dynamics, you have to learn robot control, you have to learn actually what it means to perform a task, all through this very narrow straw of action prediction. To kind of ground it in a specific example, like your VLM might have a general notion of what a water pitcher is. But that's very different than understanding exactly how and where to grab the water pitcher, and then the task of, say, pouring that water into a cup. That is something that your VLM does not understand, and that you have to learn through your action data. So the other approach that is now on Twitter quite a bit is a world model approach. This is an umbrella term, but for the focus of this discussion, I'll narrow it to a model that is conditioned on video, text, and then predicts video. There's of course many other variants, but it's the closest comparison to say a VLA. And in this case, your supervision is directly predicting video, which kind of forces the model to learn spatial temporal relationships. And then, when you're training on robot data, for instance, you don't have to learn all these things from scratch. You just have to kind of apply these priors to your robot embodiment. So I think this is a very kind of powerful paradigm. We don't even necessarily need to call it a world model, but I think using video backbones are definitely at least at 1x the way forward.
Yeah, I guess Tony right before this said no hot takes, but maybe I'll put some hot takes in. So I think that was like a really good explainer for both of those things. I think the way we think it's true that like world models can learn from a lot more data, and they can learn things that are true about the world in a way that VLAs would be less efficient in learning. I think it is also clear that world models will have a part to play in robotics for sure. When exactly that is and in what way, I think is still a bit TBD, and there does seem to be like a couple maybe revolutions of the wheel that have to happen here. There's like tractable problems that people are working on, for example, inference time, right? Like you need continuous and smooth trajectories, right? And if you're doing video diffusion all the time, if you're relying on that, that's tough. But there's definitely a lot of promise there. VLAs, depending on the task, for example, folding laundry, they work great. They work like no other paradigm yet. They get the job done. We run our models every day in new locations on new laundry. They do dynamic motions, not just pick and place. And they are able to fold t-shirts, long sleeves, pants, shorts, small towels, body towels. And I think there's echoes of
Can we keep the conversation down in the back until after the discussion?
so as like a reactive component that can produce continuous and smooth trajectories that gets the tasks done practically right now, VLAs are a great architecture.
I think hello. I think the previous answers already talked about a lot of the differences and nuances of the model architecture, what it can do, what it cannot do. I think the part maybe I can focus on is the data side of. I think the way I think about model is still is a manifestation of the data is trained on. At the end of the day, the intelligence doesn't emerge from nowhere, but from the data. And I think the way I'll think about it is that if some certain things are just missing from the data, it's impossible to reinvent it. One example of that for the video prediction variant, which is a limited variant of the world model, is that it simply does not fully understand either actions or force or tactile because those data are just fundamentally missing from the data set. And if the model has never seen that before, it will not be able to immediately understand it from the beginning. But at the same time, just by seeing videos is of course giving us quite a big boost when it comes to the fundamental capabilities. But it's not like a silver bullet, the paradigm itself, but really what kind of data the paradigm can leverage, and can it leverage more data than the previous paradigm.
How do you guys think about collecting data? Do you guys focus on, because I know for Memo, you guys have a very specialized device that you directly capture that data. I would love to hear how you guys are approaching it, whether it's through specialist devices, teleoperation, or through simulation.
Yeah, so we are a very data first company. So actually, when we started the company April 2024, we do not have a robot, and we're not trying to build a robot. We're actually building the gloves and the hands, because we know that if you look at the whole system, the whole pipeline, data is a bottleneck. It's data that will bring the intelligence, that will bring the use cases and everything else. So yeah, that's like really the singular focus, I would say, for the first year of the company. And I think the way we think about like the gloves is that it's simply a lot more scalable and a lot more cheaper and contains way richer information compared to most teleoperation system. I will not say all. Yeah. So
Yeah. We obviously use different sources of data when we're pre-training our models, but I think at the core of it, and I think this is maybe the biggest difference between Sunday and Weave is teleoperated robot data, and also autonomous rollouts. Without going into it too much, one of the reasons that we optimized for being able to build a ton of robots as like a very small team in San Francisco was to be able to generate a lot of data, whether it is being remotely operated or a model is being rolled out on it or not. And this obviously doesn't fit like the previous paradigm of like how LLMs have been trained, right? Like slurping up a ton of data and just using it. But something generally doesn't feel right to me in this moment as we're kind of like talking about like how AI, like Claude Code, all these things are like stepping into the workforce and actually doing a ton of work. And now we're talking about robotics, right? And how they're going to help in the home and help us save time. And something fundamentally doesn't feel right about having to put a lot of cameras on people or having to have like an army of teleoperators just doing work just to train a model so that eventually it will save us time. So we think that autonomous rollouts are a big part of this picture, and we're betting on that.
Yeah, I would say similarly, we're also betting on autonomous rollouts. I think generally, it's hard to get into the weeds here, but I would say autonomous rollouts are one thing. Two, Neo's humanoid embodiment is a very clear, choice for us, at least from the hardware principles, because transfer from human data is something that we definitely believe in, and I'd say there are now works kind of validating this. We should have things coming out soon publicly. Also, kind of showing our bets in similar directions. But yeah, generally, I think the data mixtures are still a bit unclear, and I think over the next year or so it would become much more clear, given the various bets that you see different companies making. But and then I think that's why you're not getting the clearest answers up here, is because we're all making bets. So
Yeah, this is we're super early to this, and I feel like so much will change in the next couple years. I'm curious, where do you guys think in the next 2 to 5 years, what will be the things that are different that we're not expecting today?
I mean, where I personally would want to see ourselves in is robots that are a lot more approachable and visible to people. This has been like a driving force in our company since day one. This is one of the reasons that we're shipping Isaac Zero to Bay Area residents, and also why we've had them in laundromats ever since from the first moment that we could. it is very important that not just like small groups of people with access to kind of like the frontier companies or people only in San Francisco can see these robots or have them in their homes. It's going to be a process to get there. But what I would love to see different in 2 to 5 years is that we're at least on a trajectory to make robots visible and touchable by most people, and then hopefully in most households as well.
Yeah, I think I also want to first ask the question of like, well, where are we see large language models or coding models in 2 to 5 years? I think we'll be living in a wild future, just given seems like we're at an exponential for in terms of capabilities. And I think I really don't want robotics to be falling behind here. We'll be living in a really strange world if the AI is doing all the intellectually interesting work, all the valuable work, but humans are doing chores, right? It just doesn't make much sense. So I think like all of us in this panel and all the other robotics companies are really just like fighting against this future that humans are left with all the repeated, all the uninspiring tasks, but AI is doing actually the fun stuff.
Yeah, just to echo the previous points, I think robots living, working among us, is the goal of all of our companies. So I hope, Neo is shaking hands with Memo and also with Weave. And so, I think that's the future that in 5 years, we should hope to expect, where, out and about, not just in your home, you actually see robots, interacting with people, daily. Yeah, I'll leave it at that.
And so for the final question, I wanted to ask, what has been some of the unexpected difficulties in deploying robots outside of the lab? And what are some learnings you can share with the audience who there's a lot of people here that's working on robotics?
Yeah, maybe I can go first here. Yeah, I remember the first deployment that we did. It was August, and it was so hard. I think just even getting the robot into a U-Haul, getting it down to the basement of this residential building, and then getting it set up there. And while we're setting things up, answering questions by people, it's like, oh, what does it do? What's it going? Is it going to do my laundry? It's like, depends. Do you want it? I think that one of the biggest challenges has been every deployment you do is a pull on your company, right? It's either logistically supporting, answering customer questions, or doing repairs when needed, or shipping out new models, fine tuning stuff because something doesn't work well there. And to balance that pull, that work with the future work that has to happen is an extremely hard thing to do as a company. um, this is something like big companies struggle with. And I think it is important, though, for us to be able to do that deployments at the same time as building for the future, because fundamentally, what I very strongly believe is you cannot build a consumer product that is like 5 to 6 years out. We learn from deployments like we learn from nothing else. And every day we make sure that we are stretched as thin as possible so we can uh, do both at the same time.
Yeah. I would say fleet operations as well is very challenging. Um, It's yeah, it's one thing to work on robots in the lab, like you have techs all around in case something breaks. And of course, like you're there to understand the failure modes of the model, and you generally do because it's kind of your baby. And so it's easy to kind of trick yourself into thinking that you have this beautiful creation, and then of course when you actually go out and deploy it in the real world, and you have to deal with network issues, and various kind of distribution shifts, and deployment, then of course everything breaks. falls apart. And that's why dog fooding has been something that we've been doing for the last 2-3 years, including with our previous robot Eve. So I think we've learned quite a bit along the way, including kind of deploying it both in U.S. locations as well as in Norway locations, which is where our company originally was. So shipping all of this stuff internationally has surfaced so many things that we didn't even think about at the beginning. In general, it's very hard to do things in the physical world. So I'd say it's one thing to kind of develop models and try and build this API layer of physical intelligence, but I think some of the biggest winners will be those that actually can successfully deploy these things and manage the fleet operations more so than even the model development or even the hardware development. If you can successfully deploy, then you will be a very dominant business.
I think on deployment is again all about trade-offs. I think two of the trade-offs that we kind of witness ourselves is one is internal testing versus deployment. What are the things that are better executed to be internally as running reliability tests or some other evaluations of the model? And what are the things that is actually better to put into a real home and see what people react to it? So this is the first point. The second trade-off is again the pull between product and research. It's very similar to frontier large language models that yes, the capability of the model is going crazy, but at the same time, a lot of the requests, a lot of the features are coming from the users. I think for us is it's really pulling both directions. That how can we build frontier research that makes it easier to iterate on the product experience, and how does the product experience inform the research directions? Because if you think about robotics research, it is such a open and early field. You can do almost infinite things, but we don't think that is best driven by just open-endedness, but having a North Star that all the research is directed towards. So that's kind of how we use deployment, use product to guide a lot of these prioritization of research questions that we work on.
Awesome. Thank you guys so much. We have a few minutes left. I want to open it up for any questions from the audience.
What are some the safety measure and the privacy measures about which place for the office or for
Yeah. One thing that
The question was, what are some of the safety and privacy measures that these robots are taking when they're deployed into people's homes?
Yeah. One clear measure for us, the first thing that we did was kind of ownership over your data. We will provide you kind of a dashboard for you to view all of the Neo logs recorded in your home. And at any point in time, you can kind of request to have this deleted. We won't train any models on your data for at least 24 hours. After that point, it may be in our models. We can still have it deleted, but it might, exist somewhere in our models after that point. But one other kind of more important guarantee as well is that humans will not actually be looking at your data. This will be directly kind of streaming from your robot into our servers, into our training pipelines. So that's very important that humans are never actually looking at your data unless there is some kind of robot hardware issue or safety issue, in which case we'll first contact you and request that we can look at your data, and only after you've said yes, do we do so.
I think it's a really important question, and it's very important for robotics right now. I think both safety and privacy are on such a different level than what we have for smartphones and stuff like this. So first of all, the way we've kind of approached this is the first robot we're shipping is stationary. So by default, both what can go wrong is very limited by that fact. And we obviously built our entire stack from the hardware, software, to make sure that we have the right system level checks in place. That's whether it's thermal, current readings, but also we get torque readings from every single joint so that if there's an anomaly, we can detect it. We also think at first it is very important for the foreseeable future to have a perception stack running to bound the outputs of the model, especially for robots driven end to end. So those are some concrete steps that we've taken. From a privacy standpoint, having it be stationary helps. Most of what the robot sees when it's folding laundry is just down here. Obviously, the wrist cameras that we have can kind of see around, and we work with every single customer we have to make sure that like the robot does not see anything that it's not supposed to see. And we not only do that, we actually think it's very important for every single one of our customers to see these robots in person. So after people have put in an order, we actually invite them over to our office. In fact, we insist that they come over so they can see their robot in action and so that we can talk to them about how to think about this thing that has two arms and moves and how to think about the cameras on them. And we think that this step is actually very important as we introduce this like new product category. I think there's so much you can glean from videos on Twitter. And we think that like the in-person component and being in constant communication with our first customers is very important.
So the question is safety and privacy and how we think about those. So I think as a robotics company, again, we by default think about it as systems from hardware, software, data operations, everything. And on the safety side, it's really a combined effort of software and hardware that, for example, our hardware, we call it passively safe. As in any configuration, you can like cut the power and it will not be falling over. And this is a very important guarantee that makes it a lot easier to reach the safety threshold. That's because once the robot is falling over, you really do not know what will happen. It can short a battery, it can start burning. So I think making sure the hardware is safe is very important. And other things are like low reduction motors that are not high inertia by default. That also helps with making sure that we are not like damaging like desks or like people around it. And then the privacy, I think for us is we really do not need to train on like the data that we collected from doing deployment, because again, the main source of data collection that we have is from the gloves. So our pipeline is going to be more like, hey, you can have feedback about what the robot is now doing as well. And those are other instructions. As an example, let's say the robot is really bad at folding neon green swimsuits after like for the laundry, right? So we'll identify that problem. Maybe the user can tell us or take a picture. And then the second day, we asked our hundreds of data collectors to go maybe your nearest Walmart and go buy these neon green shirts. And then within a day, we'll have a huge amount of data that we can use that to patch what the model is currently not very good at. So I think we think about the data iteration loop as and the feedback loop as two independent loops that are like, of course, like intertwined, but we don't necessarily need to depend on deployment data to make improvements.
Awesome. We have time for maybe one or two more questions.
But how do you position yourself against the Chinese competition? Because like they are also moving very fast.
The question is, how do you position yourself against the Chinese robot companies? Then I feel like I see new one every week and all sorts of humanoids and various other robots.
Yeah, I think if you look at large language models, I think there is almost this myth in Silicon Valley that, hey, we're so good at software, we're so good at AI, that the Chinese companies will not be able to do it, and that's how we win. But I think if you learn anything from DeepSeek, from Kimi, from all these models, that's just simply not the case. It's like factually incorrect. So I don't think we have we can be like feel so good about ourselves that hey, there is a fundamental advantage, because I don't think we do. And I think it really comes down to how fast we're iterating, how hard we're working, and whether we're working on the right thing. So it's more about decision making It's more about putting in the hard work. And I think that is the only long-term and sustained way that we can win any competition. And the Chinese robot company is just one example of it.
I really dislike this question for two reasons. I think one, labeling it as Chinese or not competition, I think is the wrong approach, or at least from my perspective. A lot of great companies in the US work with a lot of Chinese vendors to make their products a reality. The other portion is thinking about competition in the first place. This product category doesn't yet exist, right? We started shipping, but we're a small company, right? Like, there's many other entries that are going to be made into this. We are, I don't want to sound too Twitter-like, but we are so early into this journey of robotics. And I think if anything, like if you think about the early Macintosh personal computer era, if you look at Apple's timeline, if you look at any other company, like personal computer company's timeline, it's so colorful. There's so many products being built, like year after year after year, and it is so, in some way, experimental because it is this, everybody is trying to find the right product for the right time. And in this way, competition is great, actually. It pushes you to make your product better. And this is how we approach the company. We will live or die by customers liking our robots or not. If a customer likes a robot that a competitor, Chinese or not, builds better, that's on us. That's not on the Chinese competition.
The last question.
Very big questions. It's like interview all going in robotics and the good to the air totally. The thing think that next couple of can bonus की like the maybe smaller one model so be a ray or for the entire one on the array but in the seas at privacy thinking that are really
So the question is, where should the focus be in the next couple years for researchers building foundation models? And more specifically, what was the last part? Gotcha. Whether we should be building smaller world models and VLAs versus building bigger models that are generalizable.
Yeah, I think both actually are incredibly useful. I think it's not even necessarily kind of the trade-off of big versus small. I think there's actually kind of a lot of just video model priors that like we just accept. I think there's more fundamental architecture changes that we can make to these video models that maybe don't lend themselves to like video prediction. Like, you wouldn't use it in Hollywood, but it might be a much better, policy or evaluation tool than say, the, latest, greatest open source world model. I think it's also a question of like how much compute you have. So depending on that, you probably, either can or can't train a bigger model. But if you don't have a lot of compute, I think both on kind of training more efficient models, better representations will be incredibly important. Over the next few years.
I love big models. So I think the more direct answer to that is I think when we work on robotics again systems, there's so many constraints. There's latency, there's the throughput, there's a compute cost, and all those things. I think when we strategize towards tackling a problem that is complicated, a big part of the decision is thinking about what are the constraints to relax and what are constraints that we can relax and we can bring back into the future. And I think the size of the model is one of them that I think is more important that the model works as opposed to like how big it is or how small it is. Because we've seen like just the cost of compute has been going down so much and we are like 100 billions of parameter model was crazy, but these days they are not as crazy. So yeah, I think that's one constraint that I think can be relaxed, and then we can bring it back through like better hardware or model compression and all the inference tricks that we can do at deployment time.
I think I almost completely agree with that. The only thing that I would add is I think one of the things that model size really impacts is inference time, and inference time directly correlates with, is this model usable not just in offline but a real setting. So I think even if you make like a 1 trillion parameter super generalized robotics model, but it's generating like 5 milliseconds of action per 2 minutes, it's not useful, right? So it is, as Tony said, like a big balance between how large the model can be, and can you generate continuous smooth trajectories with it.
Do you think these big models will live on the robot, or eventually do they have to live elsewhere?
I think the question that like plagues the entire consumer hardware question, right? Apple struggled with it. Every company struggles with this. I think who knows where things will be in 5 to 10 years. I think that, like, to echo Tony's point, at this point, like, we're at a place where we benefit from bigger models. And then as those start working really well, these robots start generalizing across domains and tasks really well. Um, there's going to be like a paring down of models and putting more on device, but it's depending on the company and the product and how many use cases the thing has to do, it's probably going to be a mix of things.
I think we're out of time, but please give a warm round of applause for our panelists.